As seen from what we built, the arch is a structure that stays at an equilibrium due to compressing forces between the blocks that build the semicircle. As the blocks push each other, they receive reaction forces countering the initial compression, which makes them stay stable and balanced. The ends of the arch exert both a vertical and horizontal force on the table. The vertical force comes from the weight of the arch distributed throughout the blocks by their compression, while the horizontal force tends to stretch the legs of the arch outwards. However, because of the friction on our table, these forces get a reaction and the arch stays intact. The arch would also not stand if the angle between the legs and the table was such that our horizontal forces would be greater than the friction forces of the table. Our arch does not stand because it is too thin. Its shape fails the chain test, which means it does not follow the shape of a reverse chain. A solution for maintaining its equilibrium would be to apply forces on two of the top corners. This way, it is as if we are pulling our chain to those corners to fit the shape of a stable arch. By applying this force, our arch will be able to maintain equilibrium, even though it is not as thick as before. After replacing the bottom two lengths, the arch was successfully able to stand. This adjustment improved the arch as the lengths with red dots were placed at wider angles, resulting in a wider angle between the red dot and the white dot lengths, overall allowing for more friction between the pieces.
Wow, it works!
And thus holding them together, as opposed to letting them fall due to lack of friction.
And now we're coloring the arches.
Alright, so we're about to do a chain test. It's gonna be right there.
After applying the chain test to these different types of arches, it is evident that there is a correlation between shapes in which the chain remains inside the arch outline and those that stand, as the arches that were able to pass the chain test were able to stand up, whereas the arches that did not pass the chain test were unable to stand. This shows that the distribution of the gravity force throughout a chain is equal to the reversed shape distribution an arch needs in order to remain standing. A free-hanging chain takes the shape of a catenary. This design did manage to pass the chain test. The mat exerts a force of friction on the ends of the arches, acting in the X direction, as well as a gravitational force acting on the base in the Y direction. Placing one of the ends of the arch off the rubber mat and on the table results in the arch losing the crucial force of friction needed to keep it stable. This tells us that the force of friction is extremely important to ensure the stability of an arch. This design stands and passes the chain test. When the chain is hung and compared to the shape of the arch, it matches. This arch passes the chain test when compared to the previous design, because the ends of the arch are closer together, constituting for a stable base that the rest of the arch can safely stand on. We decided to go with this simple design because adding height to arches increases their chances of failure. The design passes the chain test, and it successfully stands upright with no problems. The shape that the arch takes allows for a strong base and forms a strong arch that is able to stay upright. This experiment was very informative as it taught the group a lot about how arches work, such as the importance of a strong base and a good estimation of whether or not an arch would stand depending on if it passes the chain test. The first thing we learned from part D and I of the lab was that a large percentage of the strength of an arch comes from the friction force between the arch ends and the ground it stands on. Without this important force, the arch would simply fail to stand as the weight from the top of the arch would push the ends apart. The shape of the arch makes a large difference as well. It decides whether or not the arch will stand. The arch must pass the chain test, which is essentially a test to see if the shape of an arch matches the shape made by a chain when the ends are held a certain distance apart. If the shape of the arch matches the shape of the chain, it would successfully stand. If not, there is a good chance that it will fail. These things were first proposed in the questions, and the group was expected to test and see what the result would be. Upon performing the activity, the group learned a lot of things about arches, such as the general shape they take, what makes for structurally sound arches, and what causes them to fail. Thanks for watching.